Erev Tov, Bruchim Habayim, everyone. Thank you for joining us tonight. And tonight we're going to be starting our second part of our three-part lecture regarding the halachic times, exactly what the definition of Ben Hashmashot is, what its implications are, and exactly how we view it based on halacha. If we can recall from last time, where we left off in our conclusion, we stated that there was a disagreement between both the Gra and the Geonim against Rabbeinu Tam and his followers. And the disagreement was exactly how do we determine how long the time span is between Shkia, which is sunset, and Tzeta Kochavim, the coming out of the three stars. As we already explained, that there is tremendous halachic ramifications for this. For instance, we know that 9 mitzvot, they begin at the time of Tzeta Kochavim, when 3 medium-sized stars come out. For example, we have, doing Kiddush on Shabbat, reading the Megillah, saying Sfirat HaOmer, eating a Sukkah, and so on and so forth. And since we have many mitzvot that are applied based on the time of when night starts, it's obviously recommended for us to be familiar with how the process occurs. So just to sum up, we're going to quickly write on the board what the opinions were, and we're going to see exactly how the validity of these statements. So the first one was the Gra and the Geonim. And they had 3 opinions exactly how long the period of Ben Hashmashot lasted. The first one we said was 13.5 minutes. The second was just under 17. And the third was 18 minutes. Finally, we have Rabbeinu Tam. And likewise, 3 opinions. The least which was 90 minutes. The least was 72 minutes. The second, which was 90. And the third, 120 minutes, 2 hours. So as we noted last time that there's a big problem with this, because the difference between the Gra's least opinion and Rabbeinu Tam's largest opinion is nearly 9 times the amount. So if that's the case, it's going to be a problem, because if we're saying that Shabbat ends, right, at Tzeta Kochavim, so if I follow the Gra, which is 13.5 minutes, but really the halacha follows like Rabbeinu Tam, it's 120 minutes, or even 72 minutes, I made a Chilul Shabbat, right, because it's much later. Or it could also be, we could say in the other case that we follow Rabbeinu Tam's most strict case in 120 minutes, when in reality the halacha follows the Gra 13.5 minutes, and there's a tremendous discrepancy between the two of them. So therefore, it's necessary to understand exactly how astronomically this works, and based on the astronomy and the halachic opinions regarding them, we'll be able to understand exactly what we're looking at. So this is on the side right now. I'm going to quickly erase it. But the conclusion of this lecture, we're going to put it up again and see where we're holding.
Do you want to volunteer for the board?
Oh.
No. Thank you. I need to erase something. You will erase for it. You be the eraser. Sit over there. You be the eraser.
There you go. Thank you.
Let me know.
So I'm going to throw a quick question. Anybody who wants to answer, they're free to do so. The question is the following. Which one is true? Does the sun go around the earth, or does the earth go around the sun? Answer.
Don't be so hasty to answer.
Earth goes around the sun. Are you sure? You sure? Okay, very good.
I'm sure Visas can prove it you're different, right?
He could. He has a lot of conspiracies, this man. He's very good, though. So, obviously you're right. We know today that clearly the earth goes around the sun. And the reason is, based on Isaac Newton's classical physics, at
least for now, it goes around, the earth goes around.
At least for now, based on what we know, the sun is the center of the solar system and the earth goes around it. And the reason is because since the mass of the sun is so much greater than the earth is compelled to revolve around it. right? Everything has gravitational force. Everything basically is able to come next to each other. We all have mass and we're all attracted to one another. But the reason that I'm not coming towards you or you're not coming towards me is because we will pretty much weigh the same, relatively speaking, right? Even 50 to 100 pounds doesn't really make a difference. But when we're talking about something weighs thousands upon thousands of times greater, then by default, whatever weighs less will go around the larger object. And in this case, the Earth goes around the sun. But why such a big deal about this? The big deal is because until 500 years ago, approximately, this was considered to be complete heresy. For instance, it's well known that anybody who was surrounded and lived by the Christian church, if they were to say that the Earth goes around the sun, they would have been killed. At most, or at the very least, they would put a house arrest for the remaining period of their life.
AKA Galileo.
AKA Galileo. So we have to first understand the history about exactly when the change happened and the history of exactly when these occurred, when the theory of heliocentricity appeared. So we have two definitions we have to start with, and they're known as geocentric and heliocentric. So anyone who's ever taken Latin, if anybody, we know the word centric, right? It means center. Something that's in the center of a given area.
Egocentric.
But what does geo mean? Well, let's think about it. We know the word geology, right? What does geology mean? The study of Earth, right? Or geography, the mapping out of the Earth, or the coordinations of the Earth. So therefore, according to this, geocentric means
The Earth is center.
that Earth is the center of the universe, or I can't say solar system at this point, because it would be the Earth system.
Yeah, the Earth system.
Right? Then we have heliocentric. Again, centric means center, and helio in Latin and Greek it means the sun. One of the pagan gods of the Romans and Greeks, he was known as Helios. He was the sun god, so to speak. And heliocentric they took out of it. The reason is because the sun, 85% of it is made out of helium. So we have some common denominator between the two of them. So the first one to actually claim that it was the Earth that went around the sun, his name was Aristarchus of Samos. He lived in about 400 BCE, before the Common Era. And he was very, let's see, what's a good word for it? He was heretical. Very big heretic, because around a similar time period, it was well known that both Plato and his famous successor Aristotle, they clearly stated that really the whole universe is geocentric, that it's this Earth itself that is the center of everything else, and the sun is the one that revolves around it. Therefore, anyone who were to say that the world is really heliocentric, placing the sun in the center, there's something wrong with him. He obviously does not know science well. There's something that's not clicking right. So his theory was completely disregarded, even though it took almost 2,000 years later to show that it was really the correct one. But what's interestingly enough is the Gemara Masechet Pesachim Daf Tzadik Daled says that the Earth really is what is stable, and it's really the sun that goes around it, so to speak. So we have to look at this very, very carefully, because what is very well known is that Chazal, our rabbis, they were not dumb at all. In fact, it is possible to even say that they knew more scientific knowledge than us today, which is something that's amazing, right? We know about the universities and the libraries and all the advancements of humanities that's been going on, even since the Industrial Revolution and the Renaissance, but nonetheless, we could say they knew more than us. It's amazing. We know, there's a Gemara in Masechet Brachot, Daf Vav, and it says the following, that a person, wherever he walks, there's thousands upon thousands of demons that surround him. And they can drive him crazy, they give him illnesses. And many Mefarshim, they try to explain exactly what it is. Some go literal, some go metaphorically. But I read a very interesting perush by Rabbi Aharon Soloveitchik in his book, Logic of the Heart, Logic of the Mind. And he says, in reality, these are referring to none other than microbes, germs, right? Viruses. And he explains the following, that really when the Gemara says that there's thousands upon thousands of things that surround us, what is it referring to? Germs. It makes us crazy. It makes us sick. It makes us not well. And why did they call it demons? Because imagine if we didn't have microscopes and we were to see, bacteria and germs flying around us, what would we think? We'd go crazy. We'd go nuts. Based on this, he says clearly, they knew microbiology before anyone else did, before even the biologists. That's one point. The Zohar in Parshat Emor says the following, that wherever you live located in the earth, that place, the climate is able to affect your characteristics. Right? And we talk... Gemara brings it also. So, we're talking about a man that lived in Israel all his life, but he knew basically about genetics that has not been discovered until Dimitri Mendeleev, right? Which was 2,000 years later. So clearly, we could say that Chazal was very knowledgeable about all these things. So for them to say that it was the sun that goes around the earth, it's problematic. It's problematic. But this can be resolved very simply. As following. This is a circle, but now we're going to make it planet Earth. Excuse my artistry, I'm not that good at it, but we'll have to make do with this.
You're good, just have to get better. Always stay positive.
Alright, this is the Earth, 7 continents.
It looks like a chocolate chip cookie.
And the 7 continents. And we know that the Earth spins around, right? It's not stationary, but it spins around. Which direction does it spin? It spins counterclockwise, right? Around. From left to right, all around. Okay?
From left to right.
From left to right. Counterclockwise, right? So we're going to write that over here, counterclockwise. Okay? But from our perspective, where we live on Earth, on planet Earth, if we were to stand by a beach, right? If we were to stand by a beach the entire day and see the motion of the sun, from sunset to sunrise, the entire day for 12 hours you're standing there. What would you find? You would find like this. You would find that the sunrise occurs at this point over here, and sunset occurs at this point over here, from east to west. Again, it's counterclockwise. Again, it's counterclockwise. So it shows that the reason we see the sun setting, so to speak, from east to west is because really, just as this goes clockwise, the Earth itself, when it spins, it goes clockwise. So there's really no discrepancy. So what we name this in scientific language, we call it 2 things. When we say how the Earth goes around the sun, the Earth is spinning. It's referred to as actual motion, the way it actually moves. But when we're standing on planet Earth and we see how the sun goes from east to west, even though it's not actually moving, we call it apparent motion, what it appears to be. Okay? So we could say it like this. According to the geocentric approach, which says that the Earth is the center of the world and the sun goes around it, we would hold like the apparent motion of the sun starting to rise in the east and setting in the west at the end of the day. According to the heliocentric approach, which shows that it's really the Earth that goes around the sun, we would say that it's really the actual motion of it revolving. All right. Yeah.
I am Sam.
I have green eggs and ham. Just erase it quickly. Yalla, go. Fire you. Then you're gonna be on book too.
So like this. Okay. We're going to draw it one more time. Planet Earth. We're going to do this many times through the scope, so it's probably best not to erase that at all.
Yeah, sure. Just pay attention to the clock.
Yeah, I'm looking. This is the big brown sun that we're all accustomed to.
Sun is brown?
Sun is brown. And this world is brown. This classroom is brown. Yeah. So, it's probably going to be harder to see from this point, but if everyone could just pay attention to the globe that I brought.
Okay, you do the following.
Put it up. Okay, thank you.
Board. Watch out over there, yes.
So you have to be a little imaginative for this. But imagine from, I don't know, let's say from the end of the room. From the very end of the room, maybe even farther. The sun is pointing towards the earth, giving it sunlight in order to provide day for the people on earth. So it's obvious to say, and it's reasonable to say, that since it's from such a far distance, the entire earth will not be lit up at the exact same moment, right? It has to be day at one point while night at another point. All right? So if that's the case, the only part that will be lit up is whatever is facing towards the sun, right? And whatever is facing towards the sun is exactly half the earth. Okay? Exactly half the earth. I want to give a moment. Better? Okay? So now, since the sun is going half the earth, the sunlight is penetrating into half the earth at any given moment, we could say like this, that at any given moment it is day in half the earth, and at any given moment it's night at the other end of the earth, the other half of the earth. And it would look like this.
Optics, you know, the angles. So
Angle.
hold on, sorry.
What do you mean?
This is the earth, right? This is the sun. This is only lighting here because of that.
Exactly, right.
Thank you.
Thank you. All right. So, at this point over here, if the sun is penetrating the light onto the earth, exactly half of it is day. So, from this point until the line, what a person would see if he's standing on land would be like this. That the sun is above the horizon. It's day, in other words. But for a person standing over here, where there's no sunlight.
Josh. Point. Move to the side so they have more room.
For a person standing over here, what he would see is the sun below the horizon. All right? Now, question becomes, how about a person that is located exactly where the line is? Where would he see it? Now, that moment is exactly sunset. Exactly sunset, where the sun is directly below the horizon. Okay? That's the case. This line over here is basically a shkia line. It's shkia at this moment over here. So now all we have to know is, since this moment is shkia, there must be some time period from the time it passes this line until maybe somewhere over here where it becomes Set HaKochavim. There must be some time over there where it becomes Set HaKochavim. It's an arbitrary line. We don't know exactly where it is, but at some point it becomes dark enough that 3 medium stars come out and becomes Set HaKochavim, halachic night. All right.
Let's start again.
Don't erase the earth. Probably gonna need it.
Hey, Mom.
All right. So, what we're going to try to understand right now is that there's two different qualifications, right, or circumstances in which the determination of Tzedek HaKochavim occurs. Meaning like the following. Tzedek Kochavim, in any place in the world, wherever you're standing, does not occur in the exact same time period as another location, right? You cannot say that Tzedek Kochavim is the same everywhere. You cannot say that the period between sunset and the coming out of the stars is the same. It's always changing based on location. So the first condition is where you're located. That determines when Tzedek Kochavim occurs. All right? Now, if we look at a circle or a sphere, we see the more you go towards the center, the larger the width becomes. And the more down you go, it becomes narrower and narrower until you reach the very tip of it. All right? Now, because that's the case, if I take a sphere, like this globe, and I spin it, and I spin, and I spin, and I spin, and I spin. Now, every point of the sphere makes one complete turn at the exact same time. At the exact same moment, it makes a complete revolution. All right? Now, what's interesting about this is because not every point it has the same distance. It's only the center that is the largest. Okay? Now, since the center is the largest, and it has to make a complete revolution the same time as even the smallest portion on top or the bottom, by default, it must travel the fastest. Why? Okay? We know in physics, it's taught that the velocity or speed is given by this equation. V equals delta x over time. All right? Which delta x is the distance over time. If this has the greatest distance, if the middle part has the greatest distance, and it finishes at the same time as the top, which has a smaller distance, then by definition it's going faster. So if we apply that to the Earth, what do we say? That the equator travels the fastest. Therefore, it's going to be at the equator that the time of Tzedek Kochavim will happen the fastest amount, at the shortest time. More than that, the more north you go, or the more south you go from the equator, it's going to become increasingly longer because of that.
Or short. Okay.
Right. So that's the first one. And there's a second reason also why this is the case. There's a second reason as to why where you're located makes a difference when Tzedek Kochavim occurs. We know that the Earth travels around an axis. And the axis is approximately 23.5 degrees. If you can see from this globe over here, it's not completely straight, right? But when I leave it when I level it out, it's a little crooked. It's a little tilted, right? So we call this tilt the 23.5 degree axis on which it moves around. All right? Now what's interesting is anyone who likes Midrashim, both the Malbim and the Sforno, the comment in Parsha Noach, that they say the reason we have a 23.5 degree tilt is because of the Mabul. There was so much pressure over that it was able to tilt it to such an extent.
You do know that when major earthquakes occur, it tilts also, and that's why this day becomes shorter or longer. Yeah.
Now, since there's a tilt like this, okay? 23.5.
That's the difference between north and true north. That's the difference between the two of them. So when they tell you true north, it's exactly taken like this. North, you see on topographic maps, there's 23.5 different. There's other lines. looks like United Air.
Like we said before, that at any given moment, half the earth is day, and the other half of the earth, it's night. So if we divide the line, that's exactly how it would be, in which half the earth is day, while the other half is night. And somewhere over here, it's going to be Tzeta Kochavim. Alright? Now what you see is, since the sphere is tilted, the earth is tilted, in order for it to go to this point, at any given altitude, at any given place on the globe, latitude, it's going to have to not go in a straight path, but it's going to become more and more and more curved the further up you go. Now, what the implication is that in physics we're given two definitions, and many students have a lot of problem with it, but it's actually very simple. There's a difference between distance and displacement. Anyone? What is distance? What is distance?
From one place to another.
How far you moved, right? How far you've moved. That's my distance. What is displacement? If anyone knows.
Distance from the origin.
Right. So how far I moved from my original place until where I am now. Okay? What's the implication? Imagine I'm on a racetrack. Okay? And I say this racetrack is 1 mile. I'm running around 1 mile of a circle. And I start over here. I go around, back to X marks the spot. And I'll tell you, how far did I travel? Well, I can say it like this. My distance was 1 mile because I ran 1 mile. But what was my displacement? Zero. I didn't move at all. I'm in the same place where I started. So, if that's the case, we could say the same thing. The more curved a line becomes, the greater the distance becomes. The difference between a line, a straight line and a curved line, is that if I take this curved line and straighten it out, it would appear somewhere over here. Right? Even though the displacement is the same, it starts and ends at the same place, but the distance to go there is much farther. So I have it over here as well. Even though we start and end at the same place, because it becomes increasingly and increasingly more curved, the more further north you go, the longer the distance becomes. Since there's a greater distance it must cover, Tzeta Kochavim will occur later. For that reason as well. Right. Yeah. Leave it. We have a second criteria. The second criteria and the last one, time of year. All right. This is where it becomes interesting.
Very.
Does anyone know what the shortest day of the year is?
December 21st.
Exactly. December 21st, which is
Exactly between the 20th and the 22nd.
Spring
solstice, right? Winter solstice. First day of winter. Shortest day. What's the longest day of the year? Right. 21st, 22nd. Depends on the year. Right? Around. So why is that the case? What's the whole thing behind it? I know you know. Going to draw 3 circles over here. 3 circles over here. This is going to be our Earth at different points of the year.
Use the stick so you can stand on the side. Yeah. Move more to the side. Spread the chairs. Sorry, spread the chairs so you can go in between the chairs. So you can go there, yes. Go ahead. It's good.
You good?
That's it, yeah. It's
gonna go. It's gonna fall. All right. So this is the Earth. Okay. These 3 are Earth. Is the Earth at 3 different periods of the year. The first one we're going to say is at the summer. Right? This is the sun.
Oh, it's summer. That's for summer.
Summer. Winter. And spring or autumn. Spring and the fall. Okay? Now we know summer is hot. Right? Summer is hot. Why is summer hot?
Because we're facing the sun.
Because the earth is pointing towards the sun. Since we're pointing towards the sun, it becomes a hotter temperature.
Therefore, it's closer.
Okay? So since it's pointing towards the sun, how does the tilt affect Shkia and Tzedek Kochavim?
The horizon will be closer, probably.
Let's draw it. Again, half the earth is light, half the earth is dark. And Tzedek Kochavim occurs somewhere over here. Now if we see, the path during the summer months is very curved. In order to travel, it becomes a very curved line, and therefore it has to travel a greater distance. Since it has to travel a greater distance, during the summer months, Tzedek Kochavim occurs at the latest moment because of the curved line over here. At the winter, it's also curved, but not as much. Not as much, though. Again, Shkia is here, Tzedek Kochavim is here. If you can see at every point, it's curved, but it's not as much of a curve over here. Since it's not as much of a curve, and it's slightly more straight than the summer months, the time that Tzedek Kochavim will occur in the winter is less than it will be in the summer. Alright? But in the spring and the fall, it's completely different. It's at this point that the earth is pretty much straight. To a certain extent, it's straight. And since it's straight, its travel to a certain extent will also be straight. More straighter than here, more straighter than here. And what do we know? What's the general rule? Whatever's more straight will be the less distance. Since it's the less distance, during the spring and fall, Tzedek Kochavim will occur at the earliest time. It will become earlier than winter, and winter will be earlier than summer. Alright? So when we write it down, when Tzedek Kochavim happens, we say that the spring or the fall is less than the winter, which is less than the summer months. Okay. All this is according to the heliocentric approach. All this is according to when we say that it's the earth that goes around the sun and its motion relative to the sun, and how exactly we move along with it. According to the heliocentric approach, we clearly show during the spring months, Tzedek Kochavim will occur earlier than the winter months, which will occur earlier than the summer months. Samson, please.
Yes.
But now what we're going to do is we're going to use a system that's been long gone, the geocentric approach. How would Aristotle, how would Plato, how would Socrates, how would all the great philosophers argue the same argument, but using the fact that it's the sun that goes around the earth? We have to look now at the geocentric approach, what they would say. And it becomes slightly more difficult because these are concepts that we haven't dealt with. We never learned about it in school. We were never taught about how a certain science was once held. So in order to understand it, it might be slightly difficult, but it's not impossible to grasp. All right? So we said that the first criteria of when Tzedek Kochavim occurs is location. Location, location, location. If someone's standing over here, person A, all right, we have three people standing in different latitudes on the earth. Person A standing here, person B standing a little more north, and person C standing closer and closer to the North Pole. All right? When they see the movement of the sun, when they see sunrise and sunset going throughout the year, how do they see it? How do they visualize it? So what's interesting is that it doesn't look the same in every place in the world.
Sure.
Yeah.
Maybe we'll continue. We'll do part A, part B. We're going to come out with this.
Yeah.
Yeah, just continue 5 more minutes.
So you want me to finish it 9:30?
No, because they're going to talk about RV.
Yeah.
So continue for 5 more minutes. Get to a certain point. Pause. Do part A. Then we're going to do part B after RV.
Okay. So I'll just finish this quick. All right. Part B, person B, and person C. Now, for person A, the one standing at the equator, the very center of the earth, when he sees sunrise and sunset occurring throughout the day, the way he sees it, since it's flat surface to the equator, he sees a complete circle, roundabout motion. Makes a roundabout motion the whole day. But the more north you go, what ends up happening is because it becomes more and more tilted because of the sphere, it becomes increasingly and increasingly more horizontal and curved. So person B would see it like this, sunrise and sunset, whereas person C would see it like this. And what do we know? The more curved the line becomes, the longer it takes for Tzedek Kochavim to occur. Since because of this, according to the geocentric approach, wherever you're located, the curvature of the path of the sun's travel increases greater and greater. Since it becomes greater, it takes a longer time for it to occur. Okay? That's going to finish our first criteria, and we'll be back after a short pause. Thank you.